Yesterday, someone was doing a baby reveal as a boy because we came right into the smoke when it was popping, and it was like, oh, it's a boy.
Oh, that's so sweet. I love it. All right, guys. We are at day 22. Before we even get started with this, I want you to think about something. Each term is about 30 days. Y'all, we are so close to the end of algebra. That is crazy. And you guys are doing so good. Like, it's incredible. All right. Usually about 30 days. It's between 28 and 32, just depending on how the months fall. I don't know off the top of my head how many days first term is, but it's usually around 30. Yeah.
You know when we're done with algebra altogether?
At least algebra 1A. I think that there is like a B section, and then there's algebra 2.
Right.
I'll have to look at it, but you'll be done with this class.
Okay.
Yeah. Star?
We're only a reflection of our teacher.
Oh, well,
I like that stuff.
you're very sweet. A reflection of me, but also I don't want to say a reflection. It's it shows also your work, because I could be the best teacher in the world, and if you don't care, you're not going to do well. So it's you guys that did that. You guys choose to listen. You guys choose to do the work. It's you guys. So I'm proud of y'all, really. Okay, let's start our second unit. Finally, 22 days in, we're in unit 2. All right, so for our do now today, I told you to write a sentence or two, not because I want to grade your sentence writing, but because I just want you to have something written down to reference while we discuss, just answering the following questions. So the first question, we're going to talk about this. If I want to know, for example, the average height of the students that go to this school, how should I choose which students to measure? What are some of the thoughts you guys came up with? Yes, Chance.
I chose highest and the shortest and divide by school population.
Ooh, that's an interesting answer. Okay, I'm going to write that answer down. I'm going to put some of these answers on sticky notes. Chance said maybe we could measure the tallest student and the shortest student. Add their heights together and divide by 2. So that's a way we could do it.
I think if you wanted to know for sure, you would have to measure everyone.
Yeah, there we go. That's another idea. So our first example was measuring the tallest, measuring the shortest, add them together, divide by 2. And then Joe, I just heard you say you would just measure everybody's heights, add those together and divide by however many people that is, and that would give you an average. Absolutely.
Or
Bree?
you could do like 5 from every class.
Ooh, okay.
Yeah.
Pick 5 people. How would you pick them? Are you basing it off of height or would it be random?
Random.
Okay, so pick 5 people randomly from each class.
I feel like that's how statistics work anyways.
Yeah, a lot of them do. That's how people get samples. All right, any other ideas? How could we find the average height of every student in the school? What's another idea? Anything different? Yes, Star.
But I was just wondering, I just put down what is considered average.
That's a good question. What is considered average? No, go ahead, Tasha. What were you going to say?
See, that's about what I put on there, because I would think that to find the average height, okay, I wrote, if you want to know the average height of the students in the school, I feel you first need to know what you feel is average. Like, what's the average height to you? What is average?
Yeah.
You be able to do that. Then you should choose who you want to measure by those findings.
Yeah.
And you should, what is average height, and from there move forward with your measurements for various students.
That's a great point, Tasha. I appreciate you saying that. So, we got to question ourselves, what exactly is average? What's an average height? So there is no clear answer for that. There is no clear answer. We are finding that average by surveying students. And there's so many different ways that we could do that. Statistics is one of those topics where there's a lot of variability. You're going to have answers that are different. You're going to have different ways of finding those answers. You could, like we said here, we could measure the tallest and the shortest and then just see what the average of that is. We could measure every person in the school and then average that. We could pick 5 people from each class and average. You're going to get a little bit of a different answer each time. And your answer is really going to vary based on how you decide to measure it. So we don't know what the average height is. That's what we're going to find based on our measurements. There's a lot of different ways. The only thing that we really need to keep in mind here is how we measure, how we survey people, how that might affect our answer. So, for example, if I want to know the average height of students in the school, what if we considered the kids in the child care students? If we measured their heights too as one of the classrooms, is that going to affect the average?
Oh, yeah.
Oh, yeah. It will.
Yeah.
So that's where we might need to be more specific. Maybe we need to say adult students. Maybe we want to say we're measuring just math students. But then that would change the definition of the height of the students in the school. Then it's just the math students in the school. So statistics is, I just want you to think about this. We're not necessarily answering this question. We're just getting our brains turning and thinking, what different things could we do and how are they going to affect our outcome?
Yeah, because every little millimeter is going to cause another variable.
Yeah, every little millimeter it
Yeah.
does. It causes a whole new variable and it's going to shift our answer completely. Absolutely. So we have a lot of different things we could do and we're going to have a lot of different things we come up with. Okay. That's a good discussion for number 1, guys. How about we look at number 2? Okay, so for number 2, I asked you, can I survey only students in this math class to determine the favorite lunch of the entire school? And then I want to tell you why could you do that or why not?
No, you can't.
Okay, Star, you said no. Why can't I do that?
Because you would not get a fair survey because of the
Yeah.
bias.
Yes.
Because, I mean, you have to take everybody's answer.
Mm-hmm.
And then you will have to break that down into different categories.
Right.
You know?
Right.
Sample size is very big.
Yeah, the sample size isn't very big. Absolutely. Eric, I see your hand up. What's up?
We could also be statistical outliers.
Yes. What if our class is statistical outliers? So first of all, what's an outlier? Do we know what that word means? Can you define that, Erica? What is that?
It generally means a collection of data that is well outside of what you might consider the norm, for example.
Yeah. So an outlier, and this isn't something that you need to know right now, but if you're curious, I'm going to kind of write it. Outlier. Basically, an outlier is what we would consider an exception to the data. And the data is just what we collect, what we found. Exception. And let me give you an example of that. So let's say every person in the class got an A or a B on our quiz. And I have 3 people that did not take it. And so right now it would show that their score is considered 0 because there's no points in there for that yet. If I wanted to find the average grade that we got as a class on that quiz, if I included the outliers, which would be those zeros, I'm going to get an inaccurate average. It's going to say that we got like an average of a C or a D, when in reality we had more of an A or a B average. Those outliers are going to do what we call skew. It skews the data. It's going to make it inaccurate. So sometimes whenever we are collecting examples of things, we're collecting data, we're surveying, if there is something that is way off course from the rest of the data, we like to exclude it. We like to leave it out. And that's what we would call an outlier. just something that doesn't quite fit with that norm. So sometimes those outliers are going to change. Statistics is it's not black and white like most of math. It's a little bit gray. It's more of a discussion topic than it is a 1 + 2 is 3. There are going to be different answers and different ways to find those answers. Okay? So guys, number 2, we absolutely could not just survey our class to find out the favorite food of the whole school. What if you guys, since you're here at this time of day, maybe the time of day affects what food is on your mind. It's about lunchtime. You guys are probably going to pick lunch foods as your favorite. Maybe not, but maybe you will. And maybe if I surveyed my first period math class, maybe they would pick more breakfast foods. I'm going to get entirely different answers because I'm not giving a random survey here. It's what Star said earlier, it's biased. It's biased. It's not a fair survey, is what we'll say. So let's go ahead and talk about what we're going to talk about today. Our topics today are sampling types. We're going to talk about sampling and the difference between a random sample versus a biased sample. So Star, you already got that buzzer word there, bias. And after that, we're going to briefly discuss something called line of best fit. And today is going to be a more discussion-heavy class. Not as many notes to take, number-wise, but you might have a few more words to write because we want to get those explanations in our brains and remember what each of these things mean, such as random versus biased. So if you guys are labeling your notes or anything and you're starting a section for Unit 2, Statistics, I'll give you a moment to get caught up, and then we're going to talk about the difference between those two types of sampling. And I'm going to start a new page of notes here. So if you are done with that, you can do what I'm doing. Okay. And this is Unit 2. Statistics. All right. And this is day 22 continued. All right. So let's go ahead and start by talking about types of sampling. First of all, what do I mean when I say sampling? What does that mean? Does anybody know? Any ideas? Say that one more time.
Testing.
Testing, yeah, testing could be a type of sampling. Yeah, Erica?
It's the way that you select the sets of data.
Yeah, you hit the nail on the head. It's the way that you are collecting sets of data. So whenever I say data, some of these words might be familiar to you, some of them might be a little new to you. Data is just the pieces of information that we collect. So if you want to have that written out to the side, you don't have to. I'm just going to give it to you in case you're not sure what data is. But data is just information that you collect. And there's many different ways to go about collecting that data. So all that sampling is, I want to give you a definition of sampling. Think about it like when you're at the grocery store or like at Costco, if you ever go there, they give out free samples of stuff, you know. You're going over there and you're collecting information with your taste buds on if you like the product or not. Sampling is just a, what's the word I'm thinking of? Small portion. Yeah. It's a technique or a method of collecting data. That's really all it is. So sampling is a method of collecting data or gathering information. So if I were to ask the class, okay, raise your hand if you woke up before 5 a.m. By looking at how many hands are raised, I would be sampling the data and figuring out maybe what percent of you woke up before 5 a.m., for example. We could do all sorts of sampling methods. We could sample by having you write answers down and I collect them. There's all sorts of ways to sample. We're going to talk first about the two different types of sampling though. First, we're going to talk about random sampling. So let's write random sampling. Oops. And we're going to compare it. So I'm going to write versus bias sampling. Okay, so we're talking about random sampling versus biased sampling. These are two different things. Okay, so first of all, what does the word random mean? Anybody know?
Nothing specific.
Yeah, it's not specific. Random is kind of a hard word to define, honestly.
Yeah,
it is, because whenever somebody asks me, what does random mean? I think it's like random, you know? Yeah, it's really tough to define. So let me give you the sampling definition of random, and I think that it will make a lot of sense for what we know as the definition of random. And okay, here's an example. Random can mean unexpected. We can't predict the outcome. If it's random, we can't predict the outcome. There's not going to be anything that would sway it either way. So random sampling is whenever you're sampling and collecting data, and each individual is going to have the same chance, an equal chance of being selected. So if I wanted to take a random sample of something, like if I were sampling, I don't know, I'm collecting some sort of information and I want to sample or survey people from the school, I would need to set it up in a way that it's random so every person is equally likely to be chosen. If I did it at 7 a.m., for example, that's not going to be random, because at 7 a.m. there's only a certain amount of people here every single day. Erica, you had your hand up.
I have two things though.
Uh-huh.
One is, another way you could say random is you have no selection criteria.
Ooh, yes.
So I wanted to mention that sampling can be done in layers where you have a bias selection at first and then you narrow it down.
Yes, I love that. So Erica said, and I'm going to repeat it for the video in case this mic is terrible, it won't pick you guys up. Random sampling can also be thought of as a type of sampling where there's no collection criteria. So you don't have to meet a certain requirement to be surveyed. Meaning, if I were to survey just people in my math class, that is not random. There's only certain people that can possibly be surveyed. There's a criteria there, okay? Or here's a really good example. What if I went to a basketball game and I asked all the people in the crowd what their favorite sport is? That is not random. They're probably mostly going to say basketball. It's going to be very biased. So let's give you a good definition of random sampling. It is a subset, and when I say subset, I just mean a smaller portion from a larger population. So it's a subset of individuals that are chosen from a larger set, meaning that we're not surveying or sampling information from every person. It's only a few, but it is random. From a larger set where each individual and I'll read this all together, not so broken up once I write it. Individual has an equal chance of being chosen. Sorry guys, I should write differently so you can see. My handwriting just isn't as good from this angle. Of being selected. All right, so the main part to remember with random sampling is that equal chance. And I just thought of something else. I was using that example of taking a sample of something in a grocery store. So when we are collecting data through sampling, what it means is we are only collecting a portion of it. If I was to survey every single person in the school, that would not be a sample set of data. That would be an entire set of data. Just like when you go to the grocery store and have a sample of, I don't know, a cheesecake, they're not letting you have the whole cheesecake, they're letting you try a little piece. All right. So random sampling is whenever the small amount that we're taking from the total people is, they're all given an equal chance of being chosen to collect data. So there's no bias there. Everyone has an equal opportunity of being picked. Now let's talk about biased sampling. So I'm going to write out a definition for this one as well. Biased sampling is, let me see, how could I write this better? I'm going to say biased sampling occurs or happens when some members of the population have a higher or lower chance of being selected. And the main piece here is the higher or lower chance. It means that every person does not have an equal chance of being picked. It's uneven. So some members of the population have a higher or lower chance of being selected. Is rigged. That's a great way to think of it. A biased sample is like something that's rigged. You know, like if the principal of a school is a huge basketball fan and they said, well, I'm going to take a survey from our students and figure out what the students' favorite sport is, and whatever they vote for, we're going to get new jerseys for that team and we're going to build a new court for them and this and this and that. And if he only surveys members of the basketball team, like, of course they're going to get new basketball jerseys. You know, if he wanted to get a true result, he would need to randomly sample data from the entire student population. And that could be done maybe by sending a paper survey with every teacher to give to all of their students. It would be a different method of collecting data so that it's not biased. Erica?
When you're sampling opinions and stuff from people, it's not just the people that can have a bias, it can also depend on the environment in which you live.
Yes, that is such a good point to bring up. Whenever you are sampling opinions or just data from people, it's not always just the people themselves that can cause bias. Sometimes it's the environment that causes bias. You know, like if you, let's say we ask everybody, I'm going to say food again, what their favorite food is, and we ask them during the winter time and it's really cold out. People are probably going to choose a warmer food. They probably won't say ice cream because the environment affects the way you think. Michael, did you have your hand up?
A perfect example of that.
Yeah, give it to me.
Is when they do political polling.
Mm.
A lot of times they oversample like
Yes.
red areas
Uh-huh.
to get the result they want.
Yeah, political polls are a great example of random versus bias sampling. Sometimes whenever we get into politics, people want to collect data and they might go about collecting that data in a way that they know will benefit their cause.
Agreed.
Maybe they are wanting to, I'm not going to get political here, but maybe they want something to happen. And so they're going to survey people that they know will probably have the same opinion as them. Then they're going to have this official data and see, the data says that this needs to happen. Not necessarily. You just chose people that would fit that opinion of yours, you know. So this is where, you know, statistics can get a little messy. It can get a little messy. You have to be very careful about how you sample your information. It makes a big, big difference.
Don't forget quid pro quo.
Quid pro quo. What about quid pro quo?
It's done a lot in certain sampling.
Yeah. You give me the answer that I want and I'll do this
And I'll
for
make
you.
sure you get what you want.
Right, yeah. You also have to think about, are you being an unbiased surveyor? Are you allowing people to give their honest answers? Or are you pressuring them into giving you data that you want? There's a whole lot of things to consider. Erica?
That's one reason that like Amazon reviews can be
Yes.
reliable, because
Yeah.
often sellers will say, hey, give us a review and we'll give you X% of your next.
Right. I see that all the time. I just ordered something off Amazon the other day and it had amazing reviews. I got it and it sucked. And so I'm returning it today. But then I look back at the reviews and I see there's a little green lettering at the top that'll say review of a free product receiver or something. It's like, okay, that makes sense. Like it was not an honest review. It was biased. They got some benefit from writing that review.
We bought an automatic cat laser once. And
Oh yeah?
it had great reviews, but it caught fire on us.
Stop it. It caught on fire?
What was it?
A cat laser.
It was like little cat laser that you set on a table or something and it had a little mirror. And
You are
it would
joking.
Like the laser here and there for the cat to chase, so you don't have to sit there and do this.
Wow.
Damn you, Amazon.
That is scary. Yeah, well, that's just a perfect example of being careful with bias. Bias can occur in so many different places. It's a scary thing. It is. You got to be careful where you get your information. All right, let's see if we can tell the difference between some random samples and some bias samples. I'm going to give you some examples and we're going to talk about them. All right. Let me see if I can slide this up here without showing you the answer. I need something dark to cover it up. Hang on. Let's do this. All right. Let me ask you. Oops. I just showed it to you. Okay, hang on. I'm going to give you a different one. Okay, number one was. Okay, if you didn't see it, great. I'm going to still show it to you. If you didn't see it, great. Let me zoom in. Okay, here is the first example. The situation is a principal wants to know if students are satisfied with the cafeteria food. So she decides to survey 50 students, and every one of those students is from an honors math class. Is this biased or is it random? Yes. Yes. It is biased. Very good. Very good. And here's the explanation that they give. It says, the sample consists only of honors math students, and that may not be representative of the entire student population. So for example, honors students might have different schedules or preferences, and that would make the sample biased towards a specific group. All right. Yes?
There may also be motive bias with that one.
There could be motive bias. So tell me, what do you mean by that?
Being honor students, they may feel a need to give a positive review. Whereas
Oh, that's a good point. So maybe being an honors student, maybe they feel a certain pressure to give a positive review of the cafeteria food. That would absolutely cause a bias. Absolutely. So this is not random. This is not going to give you good data. It's biased. We would not want to survey this way. Let's try another one. Okay. A company is testing a new app and they want to get feedback from the users of the app. So they randomly decide to select 100 users from their entire customer database, and that database includes people from all over the country. Is this random or biased?
Random.
Absolutely. That is random. Why?
Because it has selection, like multiples, it has multiple people.
Yeah, there's a whole lot of people that could be picked.
But no stipulation rather than.
Erica, yeah?
this does have a selection bias, but it's irrelevant because people who don't use the app
Yes.
aren't going to have.
Yes, so I'll say that on here. Erica said that there is a slight bias in terms of we're not surveying the entire world population, maybe people that don't have the app. However, in this case, we would consider it random because the population for this survey in particular is limited strictly to the people that have the app. So if you don't have the app, you cannot give feedback. You would be ineligible. All right, so let's see what the explanation is that they gave. Okay, why? The users are selected randomly from a broad customer base, and that gives everyone in the population an equal chance to be chosen. So the main takeaway here, guys, if you have a random sample, every person in the population is going to have an equal chance to be picked. It's an equal chance. There's nothing that's going to sway the answer. Every person has an equal opportunity, so it's random. Let's look at another one. Okay, here's another example. So a sports coach wants to know if athletes are getting enough sleep. So he decides to survey the basketball team at his school about how much sleep they get each night. Is this random or is it biased? Biased. Why? Yeah, he's only sampling the basketball team. The population, he wants to know if athletes in general are getting enough sleep. Basketball players are not the only athletes. So let's see what they said as their explanation. Yeah, why the sample only includes basketball players, and maybe they have different sleeping habits compared to other athletes. So the reason it's biased is because it does not represent all of the athletes at the school. It's just going to represent the basketball players. So the sample's biased. All right, let's do another one. Okay. A grocery store wants to know which type of snack its customers prefer. So the population they're trying to sample from is every customer that will come to that store. The store conducts a survey at 7 p.m. on a Wednesday in front of the snack aisle. Biased. Why is that biased? Yeah, it's only happening at 7 p.m. It's only happening at Wednesday.
The day and the location.
Yeah, it's the time, the day, and the location. They're only doing it in front of the snack aisle. What if somebody's favorite snack doesn't get represented because they just didn't happen to be in the snack aisle at that time, you know? Chance, yes.
Well, it's just, it's the only thing that they're considering is a snack, so we can actually get somebody to like a chicken on, or instead of poultry, something like that.
I like
don't think
carrots.
we're focused on, raw meat stuff.
Right.
I like to snack on my yogurts and stuff.
Yeah, yeah.
You know?
It's not going to be a random sample. This is going to be such a biased answer. Maybe a certain, you know, at 7 p.m. on a Wednesday, like, for example, maybe people with kids, they're trying to put their kids to bed, so they're not going to be there, you know. It's going to totally skew your results. If you wanted to get an accurate survey, I don't know how we would go about doing that.
Right.
I don't know. Who has an idea? How do you think we could get a more random sample if you're trying to survey every customer at the store? Yes.
You could put the survey on a receipt.
Oh, yeah, you could put a survey on a receipt so people could choose to do the survey. And yes, what else?
But that would also have a slight bias in
Yeah.
that only people who are inclined to answer surveys.
Yeah, they're also going to have a slight bias there because only some people answer those surveys. What if it's a QR code survey and you don't have a smartphone? That means people without smartphones can't answer it. You know, there's a whole lot of, if you don't have internet, you know, crazy. Tasha?
Yeah, so I think they should do a longer trial period.
Yes.
In front of their store and
Mm-hmm.
maybe just see what people will say when coming out of it. I don't want to just look in their bags and look all weird and stuff.
Yes.
So
Tasha, I love that point. So I'm going to repeat what you said in case the mic didn't get it. Tasha said that maybe we need to extend this sampling period, how long we collect the data. Guys, sometimes good data takes time. We can't always get accurate information immediately. Sometimes if we want to get an accurate sample, we need to do it over a longer period of time. There are so many factors. Yes, Chance.
It's a bit of an underhanded, non-cooperative sort of survey, but
Sure.
what it is basically like, what if there was both the name brand and the Great Value brand, and so you rotate the prices as, say, you put the name brand on the whole back, you put the Great Value one higher, and then you have different types of chips also, so you see if they flop to cheap prices or to that actually
Yeah.
one they like,
Right. So maybe it makes a difference. Are people looking for cheaper prices or are they looking for name brands? You know, so if you swap those prices and make the name brand cheaper, is that what you're saying?
I'm saying like, because they'll even choose the Great Value version, even though it's lesser quality, just because they want that type of chip that they like.
Gotcha. Okay, I see. Yeah, that is a good point to make. Absolutely.
Don't taste right, but the Great Value.
Uh-huh.
Sometimes you have to buy the real Nutty Buddies.
Oh, yep. Or my Honey Nut Cheerios. I tell you what, I tried to get the Great Value, the Honey Nut O's. It's not the same. It's not the same.
I had to go back and get the real deal.
Right. Yes, Erica.
Honey Buns, Lord
You could
Jesus.
analyze sales data, but again, you have to take into consideration the price of things.
Yes, you do have to take in consideration the price of things. Do more people buy Great Value because it's the preferred snack or because it's cheaper? There's so many different variables to consider. Statistics is a thinking topic. It's a thinking topic, guys. All right. So let's see what their explanation was for this grocery store survey. They said it's biased because the survey is conducted at a specific time and location, 7 p.m. in front of the snack aisle, and that may attract certain types of customers. For example, evening shoppers or those that are already interested in snacks. So this may not represent all grocery shoppers, and that's going to lead to a biased sample. Absolutely. So there's been some really great discussions, guys. I appreciate all that. I really do. So I think we've gotten a pretty good idea of what can happen with different types of sampling. So let's now move on to what we can do once we have collected those samples and we're working with data. So here is an example that I'm going to give you under here. Now, let's say, this is the paper I need. Let's say that I collected data from the population being just people in this classroom. So it's not going to be biased, and it's not going to necessarily be a sample, because I'm not going to just do certain people. I'm going to survey every person in the room. So let's say I collected data to see how many hours each person studied. So I'm going to write hours studied versus what score they got on their last quiz. All right. So that's an example of some sort of data I could collect. Let's come up with a few fake data values, okay? Let's say, I'll make a little chart here. Okay, let's say I have somebody that studied for 4 hours and they got an 85%. Now let's say I have somebody that studied for 2 hours and maybe they're just really good at math. They got a 90%. Let's say I have someone that studied for 5 hours. Maybe they got a 95%. Somebody that studied for 1 hour, maybe they got a 70%. How about somebody that studied for 0 hours and let's say they got a 60, they failed. They didn't study. Yes?
So far, we have a positive correlation.
Yes, we do. Yes, we do have a positive correlation so far. And guys, we're going to talk about what correlation means here in a minute. So you're ahead of the game though, Erica. You're absolutely right. Let's see. Give me some numbers, guys. Give me some examples I can put on here. I want to get lots of data. You can just throw out numbers.
3 hours, 100%.
Yeah, let's say somebody studied for 3 hours and they got 100%.
7 hours and 85%.
Yeah, maybe somebody studied for 7 hours and they got an 85%. Okay. And let's do 2 more. How about somebody else studied for
6 hours and got 75.
6 hours and maybe they got a 75%. Okay. And how about we put one more, let's do another 5 hours, and what should they get? 50. Woo. Okay. They didn't do so good. They did not do so good. This would probably end up being what we call an outlier. Most people that study 5 hours are not going to get a 50%, but it happens.
Unless they studied for 5 hours of all the wrong answers.
Right. Maybe they studied the wrong stuff. That's right. Okay. So let's go ahead and plot a graph. We're going to show a visual representation of this data and see if maybe we can sort of predict the trend that happens for hours that you study versus what you get on the quiz. So I'm going to start by drawing X and a Y axis, and we're only working with positive numbers, so I don't need to write the full 4 quadrants for my graph. I'm just going to do this upper right hand side, but I'm still going to label like we've been doing. So, which is my y-axis?
Let's say score.
Yeah, right here. And Erica, you also said the y-axis is going to be the scores. Absolutely. So I'm going to put y above score. And my x-axis is always that line on the bottom, the left to right. And that's going to be our amount of time. Usually the x-axis is a unit of time or
People.
passing moments. I think time is the best way to put it. So now let's label our little graph here. I'm going to write hours studied under here. And I'm going to give myself space to write numbers still. So I'm writing it a little below. And I'm going to label the y-axis off to the side. Let's label this quiz scores. And give yourself a little bit of space for numbers. Okay. So now, once we've got all of that labeled, we want to decide what tick marks should I be putting down here on hours studied. So why don't we look over here at the different amounts of hours. What's the lowest amount of hours studied? 0. Good. So I'm going to go ahead and right there on that intersection, I'm going to label that 0 hours. And what's the highest amount of hours that was studied? 7 hours. So somewhere near the end, I'm going to say this will be 7 hours. And now we just want to separate this into 7 equal sections. It doesn't have to be perfect and beautiful. Just try to separate it into about 7. So that means I need 6 lines in between here, I believe. So if I break it in half, this is not fun. I've never been good at making even lines. I'm going to use a ruler. Let's see if I got lucky and made, oh my gosh, it's almost perfectly 7 centimeters. That's great. Okay, so I'm going to make each section a little more than a centimeter. Okay, there we go. 1-ish, 2, 3, 4, 5. Oh my gosh. There. 1, 2, 3, 4, 5, 6, 7. So I'll label these 1 hour, 2 hours, 3, 4, 5, 6, 7. Okay, doesn't have to be perfect because we're just making a rough graph right now. We're not doing anything too particular. Okay, and then let's look at our scores. Looks like the highest score we got was 100. So we're going to make the highest point on our y-axis 100%. And then we're going to kind of evenly separate. I don't think we need to write out every number 1 to 100. You can sort of decide and decipher what you want to make each of your points, but I'll probably make a point at 50%, 75%, or maybe we could do it by tens. There's a lot of different ways.
I
Yes.
think by 5 would work best with our hand.
By 5s. We could do by 5s. Only thing is 20 numbers written out might be a little squished. I'm almost thinking we do by 10s and then we can just put points in between dots. That way we don't have to write out 20 separate numbers. But I do agree with you. If we had more space on our paper, and maybe you have more space, then you could absolutely do it by 5s. Let me see what we got here. 1, 2, 3, 4, 5, 6, 7. Okay, well, I'm just going to go, I'm going to say this is 90%. This is 80%, 70, 60, 50%. And then we don't have any scores below 50%. So I'm actually going to do this. This isn't something I'm asking you to know how to do, but I'm going to make like a break in my graph here to show that I didn't complete the scale. That's what we're doing. Okay. All right, guys. Once you are up to that point, I would like all of you to start plotting some of these points and see if we can show a visual representation of this data that we collected. So for example, I'll look at my first set here. I have somebody that studied for 4 hours and they got an 85% on their quiz. So I would start by going over to the 4 hours And then I'm going to go up to, here's 80, 85. So there's a point on my graph. And I don't want you to label them. I want you to just leave them as points because I don't want it to get too crowded. We got a lot of points to plot. Okay. I'll do another one with you, and then I'm going to have you guys kind of do the rest on your own, and I'll do them quietly as you guys work on them too. So the second one, this person studied for 2 hours, and they got a 90%. So I'll go to 2 hours on my x-axis, and I'll go up to 90 on my y. There we go. All right, now I want you to go through and plot the rest of the points. 95. Okay. 170. 060. Okay. So once you have finished plotting all of those points, you're going to end up with what we call a scatter plot. We just made a scatter plot of all of our data. So I'm going to title my little scatter plot here, it's hours studied versus quiz scores. And I don't want to rewrite it, so I'm just going to underline it. That's the title of my graph. Hours studied versus quiz scores. And if you want to label it, this is called a scatter plot. So all a scatter plot is you're plotting points and you're scattering them across a graph. You can tell this almost looks like a bit of a scattered mess. Okay. Are we able to make any assumptions or come to any conclusions from this data by looking at it? Erica?
It looks fairly nebulous. I don't think it is going to have a very steep
Yeah.
correlation.
Yeah. Erica, could you define that word you said for us, nebulous?
Undefined.
Yeah.
Cloud-like.
I love that. So I don't know if I've ever heard somebody use that word in context, but I love that. Nebulous. So our data looks nebulous, like just random all over the place, kind of cloudy, like a nebula. I love it. So whenever we plot data, like we did here, sometimes we're going to be able to see a trend. We might see that usually people that study less get lower scores, and maybe people that study more get higher scores. Now, in this example in particular, our scores were a little all over the place. They were. So there's not a whole lot of conclusions we could draw from this data. This wouldn't be considered a very good example for drawing any conclusions from the data we collected. We wouldn't be able to come up with much. Yes, Erica?
I think it might have an ever so slight inverse correlation.
Ooh, yeah, tell me more about that, an inverse correlation.
Well, if we look at the 6 dots at the top in particular, the closer to 7 we get, the more we get.
I do see that. So it looks like this person studied for 3 hours, got 100. This person studied for 5, they got 95. This person studied for 7, they got a 85. So there is a bit of a negative slope happening there.
Very slight.
very slight. There is a slight negative slope happening here as well. But then you also see something happening here, like the person that studied the least got the lowest score.
Yeah.
You know, and so if you look at it from this point, there is a possible positive, and maybe we need to consider this person that studied for 5 hours and got a 50%. Maybe that's an outlier. Maybe that should not be in our data.
It kind of fits the trend though.
It does slightly fit the trend, I will say. Why don't we look at a set of data where we will be able to draw some conclusions? Does anyone still need this? Can I go to the next page? Okay. I'm going to give you a set of data next. This is page 3. I'm just labeling my page. Day 22 continued. Okay. Let's say, let me think of an example. What kind of data would we be collecting? I had so many examples written out. Let me see if I've got one right here. How about, it's like my brain is just blank today, y'all. How about this? People that are watching the video, I don't want them to just listen to me think. I want to pause this for a moment. So, same type of situation, but let's say we are doing a different class where my students aren't all over the place getting crazy scores. So let's create that same chart. Hours studied versus quiz scores. So I'm going to write hours over here, scores over here. And let's go ahead and just write them in order. I'm going to have you label hours from 1 to 10. All right, so we've got 10 lengths of time that a student may have studied. And then I'm going to put some scores. Let's say the person that studied for 1 hour got a 52%. Let's say the person who studied for 2 hours got a 64%. 3 hours, they got a 57%. 4 hours, let's say they got a 70%. 5 hours, let's say they got an 80%. 6 hours, let's go with 90%. 7 hours, give it 85%. 8 hours, let's say this person got a 95%. 9 hours, let's give this person 100. And the person that studied 10 hours, let's give them a 97. Okay, so we have a whole new set of data. Let's create a graph again. So I need a y-axis and an x-axis. And tell me, guys, which units of measurement, score versus hour, which one am I going to label for which axis? Yes, my scores are my y values. So I'm going to write on the side here, I want to label this quiz scores. And so that means my x-axis must be measuring the number of hours. Hours studied. Then we want to label our axes with numbers. So our hours studied is going to go from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh man, I'm out of focus here. There we go. And our quiz scores range from 52 to 100%. So let me count here. 4, 5, 6, 7, 8, 9, 10. Oh yeah, I counted that perfectly. So I'm just gonna do 10% for each mark. 30, 40. Sorry guys, the statistics unit does involve a lot of writing and drawing and labeling, so your hands might get a little tired. Alright, I just labeled mine by tens. You could label yours however you like, as long as you're keeping it to scale and you're putting your points on the accurate spots. So we're just going to go one by one. Once we have everything labeled, I'm going to plot all my points. At 1 hour, I have 52%. So I'll find my 1, I'll find my 50, and I'll just go slightly above 50. Kind of an estimate for where 52 might be. 2 hours got 64. So 2, middle of 60 and 70, a little below, about there. 3 got 57, so a little below 60. 4 got 70. And again, it doesn't have to be perfect. Just want it to be somewhat in the family of being accurate. 5 is 80. 6 is 90. 7, 85. 8, 95. 9, 100. And 10, 97. Okay. Once you've got your points all plotted on your new scatter plot, what sort of conclusion do you think we could draw from looking at this data? Now that we've got it set out in front of us visually, what could we say about this?
More hours equals better score.
Yeah, in general, the trend looks like the more hours, typically the better score you'll get. More hours you study. Erica, yes?
We have a positive correlation, and it seems to be fairly high cluster.
Yes, we do have what we call a positive correlation. So whenever I say correlation, it's basically saying that these two sets of data here, this quiz score versus hour study, they are related and they affect each other according to this data. So we could conclude here that the hours that you study is going to cause your quiz score to change. If you study more, it'll cause your quiz score to go up. If you study less, it'll cause it to go down. There's a bit of a correlation there. They are related to each other. In this case, there wasn't much correlation going on. We found that with this class, it didn't matter how much they studied or how little they studied. It was super random and all over the place. So we couldn't really draw many conclusions from that. Now, whenever we do find something like this, we do find a set of data that shows a pretty consistent idea, even though there is a little variation in there, we are going to do what we call drawing the line of best fit. So what I'm going to have you do now is write off to the side line of best fit. And I'm going to circle it, and I'm going to point to it once I draw it. So once you have your data points plotted off here into a scatter plot, we can use what we call the line of best fit to help us predict data that we might not have. So what if I want to know what somebody might score if they studied for 3.5 hours? I don't have that data, but what I could do is look at the points I plotted, and I'm going to take a ruler and I'm just going to kind of estimate what looks to be about the middle of these points. I'm going to say that's pretty close. Do we agree? You think it needs to be moved at all? Works for me. Okay, so what I'm going to do is I'm going to line it up and make sure that the number of points showing under my ruler or above my ruler is pretty equal. We don't want to do this, like I don't want to make it like that where I only, like that's a little bit too high of a slope there. You want to be a little particular about it, really think about where you're putting that line. And I'm just going to draw the line here, like that. This is an estimate of what my line of best fit would be, right here. So this is what I can use to help me predict data that I don't have. So for example, using the line of best fit that you all drew and that I drew, can somebody give me a rough estimate? You might get slightly different answers from each other. Give me a rough estimate of what I asked earlier. How well is somebody going to score, maybe, if they study for 3.5 hours? About what score do you think they'll get? Let's see. So I'm going to go down here to about 3.5, which is in between 3 and 4. And if I follow that up to my line, looks like they're going to get somewhere between below 70, above 65. So maybe it's like 68, 69%. So somebody that studies for 3.5 hours, I hope that this is no sort of accurate information, because that would suck. Studying for 3.5 hours and, you know, I don't know. That'd be rough. But if we were to use that line of best fit, we can then predict data that we don't have to collect. Now, is that going to be accurate data that we can say for sure, if you study this much, that's exactly what score you'll get? No, we don't know that. This is what we can use, though, for estimation. It's what a lot of people in like the stock market, they predict trends that happen. They watch how the data moves up and down, how values increase and decrease, and they can predict using something similar to this and say, you know, in X amount of days, this one will probably be worth this much money based on the trends in the past of how this price has moved. So we can use the line of best fit and all these data points for a lot of different things. A lot of different things, guys. Okay. That's our lesson today, y'all. It's about lunchtime. It is lunchtime. Let me give you an exit ticket. It's just going to be one short question, and I just need you to write a one-word answer. You are going to tell me if the situation that I'm telling you about, is it biased or is it random? So I am going to give you this example. You don't need to write it down. I will have it saved. You just need to tell me, is this biased or is it random? So here's the situation. A university is conducting a study about students' study habits. They decide to ask just the students who are in the library at 10 p.m. on a Tuesday night. Is this biased or is it random? Write down your answer, turn it in, and you are free to go. That's going to be it today. There's no second half. No second half. Y'all deserve a break. We've been working hard. Yes.
I believe